Hey math kids, today we're going to talk about measures of center and spread in a probability density function. So the mode is defined as the value of x that maximizes f of x on the interval from a to b. The median is the value of m such that if we take the integral from a to m of f of x, we get 1/2. So it's right in the middle, right? Because the full area is going to be 1. The mean is just the integral from a to b of x times f of x. And the variance, you can see there's two different versions that we're going to be using. And then standard deviation, we just take the square root of the variance. All right, let's try an example that will hopefully make all this a little bit more clear. Okay, so the first thing is we have to check that we have a probability density function. And if we look at a graph, we're going to see, so we're going up 1 over 2. So right here would be 1. Up 1 over 2, we look at the area under the curve. All of that is above the x-axis, so we know that f of x is greater than or equal to 0 on the interval from 0 to 2. So that checks out. And then we need to find the area. We don't need to do the integral on this one because it's just a right triangle. So it's going to be 1/2 base times height. The 1 doesn't matter, and 1/2 times 2 is going to equal to 1. And so both those check out, so it is a probability density function. Now down here, it wants us to find the mode. And so if we look at the mode back up here, it says the value of x that maximizes f of x. So we want to find the maximum. And in this case, since it's like going up, it's just going to be this endpoint right here. And so x is equal to 2 is going to be the mode. Okay. The median, if we go back, it's this integral such that the area is 1/2. It's the value of m that makes that happen. So we go from 0 to m, and then we plug in our function, and we want that to equal 1/2. Okay, so we take the antiderivative, it's x squared, we divide by 2, so the 1/2 becomes 1/4. From 0 to m, we want that to equal 1/2. I think we need more room, so I'm going to get rid of this for a second. Okay, now this, we just plug it in, so it's 1/4 m squared minus 1/4 0 squared equals 1/2. This goes away because it's all 0. And so I'm going to multiply both sides by 4. We get m squared is equal to 2. We square root both sides. M is equal to plus or minus the square root of 2, but we have to be in between 0 and 2, so we can throw out that negative. And so m is just going to be the square root of 2. So basically what that's saying is if we have, if we find the square root of 2, so we have 1 here, and then like square root of 2 is right here. The area right here is going to be half the area, and then the area right here is going to be the other half of the area. So this is the value m that shows us where half of the area is. Okay. Once again, that's the median. Now we're going to find the mean. And for the mean, go back up here. We just need to find the integral of from a to b of x times f of x. So a and b are 0 and 2. And then we do x times f of x. Let's see. Oops, not that. Okay. So we multiply the x's together. So we're going to find the integral of 1/2 x squared dx. We raise that, divide by it, and then evaluate from 0 to 2. So we plug in a 2, plug in a 0, this goes away, that's going to be 8 over 6, which is 4 over 3. Okay, and then we need to find the variance and standard deviation. I'm going to erase this. And let's just move that up there. Okay. So if we go up here, the variance we see is this or this. So let's use the bottom one. So a to b x squared f of x minus mu squared. Okay. So just focus on the variance first. And so a to b is 0 to 2. And then we do x squared times 1/2 x. We simplify that. It's going to be 1/2 x cubed dx minus mu x. So we raise this to 4, divide it, it's 1/8, evaluate from 0 to 2, and minus mu squared. Alright, bring that up here. We're going to get 1/8, 2 to the 4th, minus 1/8, 0 to the 4th. This goes away. 2 to the 4th is 16. 16 over 8 equals 2. So we have 2 minus mu squared. If you remember our mean, I don't have it written down, but it was 4/3, and that's what I'm going to plug in here. So 2 minus 16 ninths. If we change this to get common denominators, it's going to be 18 ninths, and if we subtract that, we get 2 ninths. Okay. And then when we're finding the standard deviation, all we have to do with this is take the square root of the variance. So the square root of 2 ninths becomes the square root of 2 over the square root of 9, which is the square root of 2 over 3, and that's our standard deviation. If you need additional help, please come to Math Lab. Until then, calculator.